Okay, we're back. And right now we're going to cover the second type of molarity calculation. This is calculation where we're actually going to have molarity in a volume. We're going to be able to figure out how many grams of the substance we actually put into it to begin with. Now let's do a review. We know that molarity equals moles divided by liters. Okay, in this case, yeah, we'll just call it liters. Easy enough. Now, but this is if we were solving for molarity. We got to go the other way. In fact, we've got to solve ultimately for grams. But to get to grams, we have to have one thing first. We've got to be able to know our moles. So what happens is we actually have to solve for moles first. So basically, we're going to rework this equation. We're going to kind of reorganize it. I'm going to solve for moles. So basically, algebraic manipulation. And we're going to get moles are going to equal liter times molarity. So this is a new equation we're going to work with. Moles equals liters times molarity. But I'm going to have you do one last thing. There's one other piece I'm going to have you do. I'm going to have you do this. Liters times, I know molarity itself equals moles over liters. That's what we originally had on our basic equation. So I'm actually going to have you take that and switch it back into moles over liters. Once again, remember we said it was mole over technically 1 liter, right? So we're going to now use this as our main equation. This is going to be the second equation we use. That's the key. And you're going to be using this when we do this type of problem. So I said, okay, if you want this concentration of a substance, I want this amount of it, how much of the stuff would you dissolve in? Okay, if you're going to make chocolate milk, it says, okay, for this 8 ounces of milk, you're going to add so many tablespoons of the chocolate powder. Okay, they do that because they want a very consistent amount of chocolate, basically chocolate milk flavor all the way through. So they're telling you exactly what the recipe is. This is what you're telling me, how much of this in this volume to make this concentration. That's what we're looking at here. So this is the main piece that we're looking at. Okay. So this is the equation that we're going to be working on. And you're going to notice that I'm actually going to be writing this up each time. I actually am going to write it on this format here, moles equals liter times molarity. And I'm going to mentally every time switch to this as soon as I start the work. And you'll see what I mean as we go through this. So let's go ahead and look at the odd problems. Yeah, I know we're started at 10, but that's okay. So on here, first thing I'm going to do, and you're going to notice that I do this each time, write out the equation I'm working with. Moles equals liters times molarity. That's the key piece. Okay. So I'm going to look through the problems that I have. Notice I've got the substance of NaOH. Well, we know that if I'm going to take this and pop back here for a second, if I'm looking at moles, well, I'm going to ultimately need to go and do one last step. I'm going to have to be able to convert from moles to grams. And we talked about that before as to how to do it. Remember, 1 mole of a substance equals the mass of that substance. And that's why we used the molecular mass sheets and went through that. And these are actually in Classroom already, so you can just take as many as you want. Sorry, it's not a Google Doc, so you can't just plug in stuff. But you can always do it on paper if you wish. Okay, so here we go. Once again, if you have questions on this, we can talk during a Zoom meeting. Not a problem. So I'm going to start off liters times molarity. I'm going to say, okay, well, here's my 1.5 liters. And we take the first thing, whatever it is, and we put it over 1. Now, times the molarity. There's my molarity. But remember I said I wanted you to change that molarity in to moles over 1 liter. So now the 2 molar becomes 2 moles of NaOH over 1 liter. Because remember, molarity is moles over liters. These are the same thing. I want you to convert it out like this for one main reason. Notice the liters now can cancel out. So I'm just left in moles. So easy enough so far, right? We're just following this equation. It's a base equation. We just plug and chug, put the things in. But that's great, but we're not done yet. We need to figure out how many grams. That's our target. Now I have moles, and I can easily change moles into grams. So we're going to go through, and this is what we've already been doing. We did that in the last unit. Now I have moles. I want grams. Remember, what you're looking for always goes up top. The thing you want to get rid of goes on the bottom. Once again, keep the units and formulas with, because ultimately you're going to change to do different stuff. Okay, whenever I go from moles to grams or grams to moles, my mole value is always 1. Now we would need to get the molecular mass of NaOH. Well, I've already done the work for that. And once we go through and we look at all the pieces we fill out the chart, we're going to find out it's 44.0. Not 40.4.0, sorry, 40.0. Now we go through and we have that. And make sure everybody understands how we're getting it. So now we're going to go to 1.5. We're going to multiply by everything on the top. So times 2 times the 40.0. I hit equals. Now if I look, everything on the bottom is 1. So because it's 1, I actually don't have to do anything. I'll put it in anyway, saying, hey, what do you know? We got the same answer. So calculator is going to spit out an answer of 120. Now we have to go back and look at significant digits. Okay, we have to apply that because remember, these are approximate answers. They're not full answers. So we can't say exactly what our answer is going to be. We just get close. So on 1.5, there's 2 sig digs. On the 2, there's 1 sig dig. On the 40.0, there's 3 sig digs. Remember, your answer is always based on the least number of significant digits. In this case, it's going to be 1. So there's my 1 sig dig. I look 1 spot over. Can it round? Nope. So 1, but I've got to remember that was 100. So it still has to be 100. These become zeros. They're just placeholders. So it's going to be 100, well, 100 what? 100 grams of NaOH. And that's my final answer. So pretty much straightforward doing this. We worked last week on converting from moles to grams. So we just added one small step, basically multiplying by a volume. Okay. So let's work out number 13. And you're going to find out it's following the same format. All the ones on this back side are following the same format. Moles equals liters times molarity. So here's the one thing we talked about this earlier in the other video. We said milliliters. There are 1,000 milliliters in 1 liter. Well, there's 1, 2, 3 decimals. So the conversion factor, if you want to do it the shortcut way, the easy way, is we're just going to take the decimal right here is implied right there. We're going to move it 3 spots over. And because it's less than 1 liter, the number has to be smaller. So we're going to move it over 3 spots to the right. So got to bring in a 0. There's my 4 and the 5. So 45 milliliters is equal 0.045 liters. So every time you see milliliters, just move it over 3 spots. Okay, pretty straightforward. And I don't need to see the work on anything like that. If you want to show it, that's fine. Take our volume, put it over 1. Multiply it by the molarity. Remember I said change the molarity into what it actually equals. So I'm going to go moles over 1 liter. Notice this time I gave you the name. So you have to be able to change it into the formulas. Well, there's sodium. Sodium on your periodic table, you're going to see it's a +1. Carbonate, CO3, polyatomic ion. So you look at the bottom of your chart, you're going to notice it's a -2. We cross them down to make a stable compound. So Na2CO3. Okay. Liters are gone. Now I need to get into moles. Or I'm sorry, we've got to get into grams from moles. So moles are going to go on the bottom because they've got to cross cancel. Thing you're looking for goes up top, and once again, we're looking for grams. And I already did the work on this one. So going through Na2CO3, took the formula, number of atoms, went through, filled out the table, and notice every single one of these had something in the tenths position. Therefore, I'm going to have a tenths position in my final answer. So 106.0. And now with that, 1 mole, because remember, molecular mass always equals 1 mole, and that's an infinite number of sig digs. Okay. So now we're just going to go through and do the math. 0.045, get the glare out of there, times the 12, times 106.0, and that's going to give me a calculator value of 57.24. I'm going to double check that. Doesn't take long, but can save you points. 57.24, we're good to go. Now I adjust for sig digs. Well, in the 0.045, remember that 0 is just a placeholder. So there's 2 sig digs there. In the 12, there's 2 sig digs. In the 106.0, that means we've measured out to that level of precision. So there's actually 4 sig digs there. My answer is limited to the least number of sig digs. So we're going to go to 2, 1, 2. There's my line. I look over one spot. It's a 2. Can't round. So my final answer becomes 57. 57 what? Well, grams. Na2CO3. That's my final answer. Oops. Cross out the moles since they're gone. Okay, I'm going to work out one last one, and then we're going to wrap this up because this is a longer video than I wanted. So I'm going to go relatively quick. I'm just going to mimic what I'm doing on the prior one because I'll run the same process. Milliliters convert to liters. Move it over 3 spots to the left. 1.1 molar, 1.1 moles. Iron 2 phosphate. That Roman numeral 2 means it's the charge of +2. Phosphate's PO4. Charge of -3. I cross them down to make it stable. And that's over 1 liter, because remember, molarity is moles over 1 liter. Liters cancel. I'm in moles, but I got to get to grams. What you're looking for always goes up top. And I've got, get rid of moles. Moles go on the bottom. Have to cross cancel. So some of you, if you're not including units, you're going to end up putting your numbers in the wrong spots. Remember, right now, we're putting 1 next to the mole value. So the molecular mass of iron 2 phosphate, already worked it out. It's 357. I'll put it up, so if you want to freeze the video, you can look at how we get this. 3 times 55.8, calculator goes to 167.4. So 7. But I only get 3 sig digs, so that means it becomes 167 before can't round. And all the rest goes through. Notice where I drop my line, it's the last place over. so I don't get the 0. It's just a straight 357. And I don't know if you guys can still hear me or not. My computer just shut down. Okay. Yeah, hopefully you guys were able to still do stuff. Maybe you finished the problem without me. Who knows? 0.056 times 1.1 times 357. 21.9912. I'll double check that. 0.056 times 1.1 times 357. 21.9912. Go through. I adjust for sig digs. I got 2 here. I got 2 here. I got 3 here. So we're going to go with the least number. Cut it right after the second one. I look one spot over. 5 or greater, so it does round. So that becomes 22. 22 what? 22 grams of Fe3 PO4 2. And that, my friends, is my final answer. I didn't work out 17. It'll be posted as the key at this point. Notice we're doing the exact same process. All of these are the same thing. Okay. So with that, there you go. And talk to you later.